Hello. Let's talk about network slicing. To implement network slicing, FlexE and channelized sub-interface technologies need to be used at the physical link layer. FlexE hard isolates resources based on time slot scheduling, with extremely low interference between different FlexE interfaces. So FlexE can be used to carry services that have extremely high requirements on delay and delay variation, such as the differential protection services of power grids. Channelized subinterfaces use channelization technology to divide a physical interface into multiple logical subinterfaces, with bandwidth resources guaranteed for each subinterface. So, different types of services can be carried and isolated between industries like healthcare and education. Let's consider channelized subinterface configuration a little further. How are channelized subinterfaces configured on a network consisting of two devices? Assume that device A and device B carry two types of services. One requires 100 megabits per second bandwidth, the other 200 megabits per second. To ensure SLAs, we configure channelized sub-interfaces to carry the corresponding services. But before configuration, some preparatory steps need to be taken. To begin, check that the interface interconnection is normal. For example, see if boards successfully register and if the optical module interconnection environment is normal. Next, if the interface isn't a GE interface, apply for a channelized sub-interface license. Once these simple steps are complete, configuration can begin. What does the configuration roadmap look like? If the interface isn't a GE interface, it's time to activate that channelized sub-interface license first of all. Afterwards, configure common sub-interfaces. Finally, enable channelization on the sub-interfaces and configure bandwidth for them. Let's go through configuration specifics. First, activate the license. For non-GE interfaces, remember the channelized subinterface license needs to be activated. Now configure common subinterfaces. Channelization can be configured on .1Q subinterfaces and Q-in-Q VLAN tag termination subinterfaces. Select the corresponding configuration based on actual scenarios. .1Q is commonly used to terminate a single VLAN tag. In some instances, a Q-in-Q VLAN tag termination subinterface needs to be configured to terminate double VLAN tags. For example, if users and services need to be differentiated on a user-site device, or if user-side VLANs are insufficient and another VLAN tag needs to be added to extend VLAN space, configure a Q-in-Q VLAN tag termination subinterface. For network-side devices, if a private line or private network packet sent by a third-party device contains double VLAN tags, also configure Q-in-Q VLAN tag termination subinterfaces. For .1Q subinterfaces, ensure that the IDs of the VLANs associated with the interconnected subinterfaces on both ends are the same. For Q-in-Q VLAN tag termination subinterfaces, ensure that the outer VLAN ID and inner VLAN ID of the interconnected subinterfaces on both ends are consistent. After configuring subinterfaces, enable channelization for them. The default bandwidth of a channelized subinterface is 2 megabits per second. Adjust bandwidth as required. Note that the total bandwidth of subinterfaces cannot exceed the bandwidth of the main interface. The same bandwidth should be configured for subinterfaces carrying the same type of service. If different bandwidth values are configured, the minimum bandwidth takes effect. After configuration is complete, run the command to query the physical states and bandwidth values of the channelized subinterfaces. If the main interface is down, the corresponding sub-interfaces are also down. The sub-interfaces can be used only when their physical states are up. Currently, channelized sub-interfaces are mainly applied to network slicing. When configuring channelized sub-interfaces in network slicing scenarios, there are things that must be paid attention to. So be sure to enable IPv6 on both the main interface and its sub-interfaces, configuring an IPv6 address on the former. In addition, run the IPv6 address autolink local command on a sub-interface to automatically configure a link local address for it. Otherwise, the IPv6 protocol status of the sub-interface is down, and IPv6 traffic cannot be forwarded. Channelized sub-interface configuration is now complete. In summary, key configuration points are to configure common sub-interfaces, enable channelization, then configure bandwidth for them as required. Thank you for watching.